Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring writing linear inequalities in two variables. Now, we're going to explore two situations. One where you're given a graph and expected to write the linear inequality. And secondly, we'll be giving a real-world situation where you're expected to write the linear inequality in two variables. Let's start for when we're given a graph. So in problem A, we're given a graph and they're asking us to write an inequality. So this is very similar to the process you used for writing equations of equalities or just lines. The only difference is here a portion of our graph is shaded, and that's how we know it's going to be an inequality. So you still start the process the same. You have to find the slope and the y-intercept, but additionally you'll be having to determine which inequality symbol to use. So let's start with the slope. I'm going to choose two friendly points on this line. How about the y-intercept of -4? And let's see, I need another friendly point. How about right here? So our rise over our run would be up 1, 2, 3, and run would be 1, 2, 3, 4. So our slope is 3/4 or 3/4. Our y-intercept was -4. And what symbol do we use? Well, this is shaded above the line, which means it's greater than the line. And because the line is solid, we'll use an equal to line under there. So our symbol is going to be greater than or equal to. So my inequality will be y is greater than or equal to 3/4 x minus 4. All right, look at problem B. Here we have an inequality that is graphed with a dashed line, but we're still going to start it the same way. We need to get our slope and our y-intercept. Now let me zoom in on this a little bit. It looks like we have a y-intercept of -4, and I need another friendly point. How about right there? So I'm going up 1, 2, 3, and over 1. So my rise is 3, my run is 1, which reduces to just 3. The y-intercept is -4. Now, this particular line is shaded below the line. And when the line is shaded below, we use less than. Now, we have to decide if we should put a solid line under our less than symbol. But because this is a dash line, we do not want to add an equality symbol under the less than. So the only symbol we need here is less than, all right? Now, when you go to write your inequality, we'll just say y is less than 3x minus 4. All right, now in our next inequality, we have a negative slope. So let's get our slope here. We have a y-intercept at 9, and we need another friendly point. How about right here? So we're going, if I start from the bottom point, I'm going up 1, 2, 3, and left 1, 2. So up 3 and left 2 would give me a slope of -3/2. Our y-intercept is at +9. Now we have to decide how this line is shaded. So this line is shaded below, which means I'm going to use less than. And because it's solid, I need to add a solid line under my symbol. So my symbol is going to be less than equal to. All right, now let's put all three pieces of information together to write our inequality. Y is less than or equal to -3/2x plus 9. All right. Next graph, we have a horizontal line. And so our slope is going to be 0. Our y-intercept is going to be -4. It's shaded above the line, which means we use greater than. And because it's solid, we need to add a solid line under our symbol. So greater than equal to. All right, so my inequality, y is greater than equal to. Now, because it's 0x, I don't really need the x. And so I'm just going to put -4. All right, example 2. A customer is ordering hats and t-shirts from an online store. Each hat costs $7 and each t-shirt costs $10. The customer receives free shipping if the amount of the order is over $100. The graph representing this situation is shown below. So here we have a graph. We have number of hats plotted on the x-axis and number of t-shirts plotted on the y-axis. So in part A, they want us to write an inequality to describe this situation. So let me go back and I'm going to highlight here what's going on. We have each hat is $7, each t-shirt is $10, and we get free shipping if the amount of the order is over or more than $100. So I'm going to say that 7H for 7 times the number of hats plus 10T for 10 times the number of t-shirts. If it's over or more than $100, they get free shipping. So there's our inequality. Part B. If a customer ordered 10 hats and 7 t-shirts, would they get free shipping? Justify your answer graphically and algebraically. So let's start algebraically here. And I'm going to plug in for the number of hats. I'm going to plug in a 10. For the number of t-shirts, I'm going to plug in a 7. And I want to know, is all of that more than 100? So 7 times 10 is 70. 10 times 7 is also 70. Simplify that. 70 plus 70 is 140. So did the amount they spend, is it more than 100? And this is a true statement. So yes, they would get free shipping. Now, to show us graphically that they would get free shipping, I would plot the point 10 hats, 7 t-shirts, or 10 comma 7. So over 10 and up 7. And notice that falls in the shaded region, or it falls in the solution set. So we proved our answer with algebra and with our graph. All right. Problem C. Why would the customer not receive free shipping if they purchased 8 hats and 4 t-shirts? All right, so this time I'm going to plug in 8 for the number of hats, and then 4 for the number of t-shirts, and I want to know if that is greater than 100. So this would be 56. And this would be 40. So 56 plus 40 is 96 is greater than 100. Well, that is false. Therefore, it is not in the solution set. All right, now we're also going to graphically test the point 8, comma 4. And let's graph that on our graph. So 5, 6, 7, 8. And then 1, 2, 3, 4. So it's almost getting free shipping. It's very close to the line, but it's just under the amount they need to get free shipping. All right, example 3. The members of a school choir had a fundraising drive last month. They sold candy bars for $2 each and cans of popcorn for $5 each. To meet his goal, Brent had to sell more than $300 worth of candy and popcorn altogether. So let's highlight here our important information. Candy bars were $2 each, cans of popcorn were $5 each, and he had to sell more than $300 worth. So in part A, they want us to write an inequality to describe this situation. So I'm going to say that 2 times the number of candy bars plus 5 times the number of cans of popcorn has to be more than, so that would be greater than, 300. So there's our inequality. All right, now in part, that should say part B. In part B, they want us to use the intercepts to graph the inequality. Now, it might be a long time since you've learned about graphing with intercepts, but basically what you do is you take the C part and make it equal to the constant term, which is 300, and then you take the P part and make it equal to the constant term, which is 300, and then you just solve for C and solve for P. So to solve for C, I would divide by 2 to get 150. So that's where our line will touch the C axis, the candy bars. So that would be at 150 right up here. All right, now we're going to get the intercept for the number of cans of popcorn. 300 divided by 5 would give us 60. So that's where the line will touch the cans of popcorn, and that would be right here. Now, I want to connect these two dots with a dashed line, because if you look at your original inequality, there's no solid line under that greater than symbol. Now, I will warn you, this is kind of hard to do on my iPad, so I'm going to draw this straight, but please try not to laugh at my sketch here. I'm going to try to draw me a dashed line connecting the 150 and the 60. So, okay, that's about as good as I'm going to get. Not perfectly straight. In real life, I would like to have a straight edge to draw that, but with the iPad, it's a little bit more difficult. All right, now we're not quite done because this is an inequality and we need to shade the solution set. So I want my solutions to be more than 300. So more than means greater than, and greater than means above the line. So any combination of cans of popcorn and candy bars that are above the line would be a solution to this inequality. So in part C, it says, will Brent meet his goal if he sells 10 cans of popcorn and 40 candy bars? Explain your answer algebraically and graphically. All right, so let's go back to our original inequality here. We had 2 times the number of candy bars plus 5 times the number of cans of popcorn, and we want that to be greater than or more than 300. So I'm going to plug in. It said he's going to sell 10 cans of popcorn, so that would go there. 40 candy bars, so that would go there. All right, now let's simplify this. This would be 80 plus 50, and that would be 130 is greater than 300. So that is false. So no, he will not meet his goal. All right, now we're going to show it algebraically. We want 10 cans of popcorn and 40 candy bars. So 10, 40 would be right here, and clearly that is not in the solution set. So graphically, it is no solution either. All right. Example 4, a grill at a barbecue restaurant will be used to cook sausage links that are 2 pounds each and briskets that are 6 pounds each. No more than 120 pounds of sausage links and briskets will be cooked on the grill. Write an inequality in standard form to describe this situation. So I'm going to say 2 times the number of sausage links that are cooked plus 6 times the number of briskets that are cooked have to be no more than, so they have to be smaller than or less than 120. Now, can they equal 120? Yes, because we're still at no more than. Even if I'm equal to 120, I didn't go over, so I'm no more than 120. All right. In part B, they want us to use the intercepts to graph this situation. So let me just review with you how to do that. You take the 2s and make it equal to the constant, which is 120. And you take the 6b and make it equal to the 120. So 120 divided by 2 is 60. So on the number of sausage links, the intercept is 60. Here for the number of briskets, 120 divided by 6 is 20, so that would be 20. And then I want to carefully construct this line with a solid line this time instead of dashed. So I'll try to draw the solid lines a little easier to do on the iPad. That looks pretty good. There's my solid line. All right, now we have to figure out where to shade. Since it has to be less than the line, that would be below. So, oh, look, I erased my line on accident. Let's try that again. I need a pen, not a highlighter. Let's see, it's supposed to be right there. Connect. And we were saying that if it's less than the line, that's below the line. So we're going to shade this portion right here. Represents the solution set for the number of sausage links and briskets that the restaurant can make. So in part C, it says, can the restaurant cook 20 sausage links and 20 briskets? Justify your answer graphically and algebraically. So let's start algebraically. 2 times the number of sausage links plus 6 times the number of briskets has to be less than or equal to 120. And they want to know if we can cook 20 sausage links and 20 briskets. So I'll put a 20 here and a 20 here. So 2 times 20 is 40. 6 times 20 is 120. And that would be 40 plus 120 is 160. Less than or equal to 120. So is 160 less than or equal to 120? That is false. So no, they cannot cook that number of sausage links and briskets. Now, let's just plot the point 20, 20 and show you that it's right outside of the solution set. All right. Now, let me show you a way that writing inequalities might be tested for you on a standardized test. So look at example 5. Which inequality is best represented by this graph? Now, the first thing I want you to notice about this graph is it's a dashed line. So if it's dashed line, they have to use either less than or greater than. They cannot use a symbol that has a line under it. So cannot use less than equal to, cannot use greater than equal to, because those have solid lines under them, which means I don't even have to think about answer A or answer C. So generally, when you're on a standardized test, you can usually get rid of 1 or 2 unreasonable answers. Here, we were lucky because we were able to eliminate 2. And now I've got a 50-50 chance of getting it right. So even if you have to guess, you've got a higher chance of getting it correct. All right, so since these 2 remaining inequalities are written in standard form, I'm going to use the intercept method to determine which answer is correct. So on B, we have 4x plus 7y is less than 49. So I'm going to do 4x equals 49 and 7y equals 49 and get my intercepts. So here, I'll take 49 and divide it by 4, which would be 12.25. And here, 49 divided by 7 will be 7. So it's supposed to hit the x at 12.25. No, it hits the x at 4. So this cannot be the right answer. Now, let me prove to you that D is the correct answer. Let me get the intercepts of D. 7x equals 28 and 4y equals 28. If I divide by 7, 28 divided by 7 gives me 4. Here, 28 divided by 4 gives me 7. So answer D says I should hit the x at 4, which I do, and I should hit the y at 7, which I do. So answer choice D. And that concludes today's lesson, writing linear inequalities in 2 variables.